Welcome back. We're looking at two matrices in row echelon form. These are supposed to represent their corresponding system of equations. So if we look at part A, this is supposed to represent the 2x2 system. You notice what type of matrix we have. The augmented matrix is a 2 rows by 3 columns. And if they're already in row echelon form, what that means is you've got yourself a diagonal of ones from the top left to the lower right. And the lower left triangle is a 0. There's not much of a triangle right there. Let me see if I can draw it a little nicer for you. We'll do this in green. There we go, a little triangle of zeros. So we know this is in row echelon form. What we can do is write the corresponding linear system of equations. So what I like to do is remind myself that when I read these matrices, we do have an X column that comes first, the Y column, and then we have a constants column. So what each number in the matrix stands for is the coefficient of the variable. And then on the other side, we have this little line with the equals. That's going to give us the constants. So the top row should help us out. This is going to be 1x plus 4y equals -2. And we don't have to write the 1. If you realize that's usually, we don't see that when we write the system of equations, so I can erase that. So x plus 4y equals -2, and let's make sure the x looks like an x. The second row, you'll notice that you have a 0. So 0x plus 1y, and then we'll have equals -6. Now, another thing you got to remember is that if there's a 0, you really don't have a variable. 0 times x is 0, so we can erase that x. And again, with the 1y, we can erase that coefficient because this is what we really have. So the cool thing about row echelon form is it usually provides the solution to one of the variables right away. So can you see? The y equals 6, or it should be -6. And what we mean by back substitution is we take the value of the variable, usually it comes last, and you plug it into the previous equation. So I'm going to leave myself a little bit more room. Let's see. I can take the x, I'll keep that here, plus 4 times -6 equals -2. And now we have an equation in one variable. So we'll proceed to solve this. So we will have x minus 24 equals -2. And once we add 24 to both sides, we shall get x equals 22. So now just by using back substitution, having the augmented matrix in row echelon form, the solution to part A, remember everything's always in XY form, ordered pairs, we should have 22 and -6. So that was a nice system of 2 equations and 2 variables. I would like to move a little bit forward with a system of 3 equations and 3 variables. See if I can move a little bit over to the left so we have a little more room. There we go. What we'll be looking at, just trying to help you remember, is we do have ourselves a three rows by 4 columns with this augmented matrix. And if you're looking to verify that you're in row echelon form, remember you do see a diagonal of 1s from the upper left corner to the lower right. And again, there is a lower left triangle of 0s. So we'll go through and remember, we're going to write the corresponding linear system of equations, reminding ourselves that we do have an X column that comes first, a Y column, and then this time a Z column. And again, we have the column of the constants. So let's write our system. With the top row, I'm looking at 1x, so we're just going to say x, plus 2y minus 3z, using those numbers in the entries as the coefficients of our corresponding variables. We do have that bar one more time. So we have the equal sign, and we should have 8. We're going to take the next equation. Notice that I'll erase this lower triangle of 0 so that you can really see. We do have 0x, so we do not have to write that down. We do have 1y plus 8z equals -7. And finally, the third row, notice that there are 2 zeros. So we have 0x plus 0y. We don't have to write the x or y variable. Plus 1z equals -1. So right away from the row echelon form, we see that we have the value of one of the variables. In this case, it's z. And what we'll do for ourselves is use back substitution to find the value of the previous variable. So I'll take a little bit more room vertically. I'm looking at plugging in z equals -1 to the equation y plus 8z equals -7. So a little bit of math. We'll simplify. 8 times -1 is -8 equals -7. We will add 8 to both sides. And we should get y equals +1. So now we have the value of the second variable. So from there, back substitution basically means we're going to take the z from our first solution and also the y from our second solution, plug that into the top equation, and get the final value of the variables. So let's go to the right a little bit. I don't know what x is, but I do know that y is equal to 1. Then we have -3 times z. In this case, z is -1. And this shall be equal to 8. So just take a little time simplifying. We should have x plus 2 plus 3 equals 8. And once we do this, let's simplify a little bit more, combine the like terms. We have x plus 5 equals 8. We will subtract 5 from both sides. And we will get x equals 3. So finally, for this part, our solution is the ordered triple. Remember that x comes first. So that's 3. Y comes second, that's 1. And z comes last. So that is -1. And that's how you use back substitution to actually solve the system of linear equations.